So today's presentation is on a concept called similarity, and we're going to look at what makes images similar, what makes it when images are non-similar, and then specifically we're going to look at triangles and talk about what makes triangles similar. So here are some examples of similarity. Let's start with an image. And so for the image, I chose a cow. And for images to be similar, they must be proportional. So there's my image. It's made bigger, but it's still proportionally the same. Here it's made smaller. Here I've rotated it around. Here I've reflected it. Here I've done a combination of rotation, reflection, and making it bigger. But these are all similar images. And the reason they're all similar is because the proportions of the images stayed the same. As it got X% taller, it got X% wider. So we say that the ratio of the image's height and width remained the same. Here's an image of that same cow, but it's made wider and not taller. Here's the image of the same cow that's made taller and not wider. So these changes were not proportional. So these images are not similar images as the ones above. When we're looking at polygons, they must have congruent angles. So in this case, I say that angle A is congruent to angle Z, angle B is congruent to angle X, and angle C is congruent to angle Y. So the measures of all those angles must be the same if these triangles are similar. Additionally, they also have to have proportional sides. So the ratio of whatever AB to ZX is going to be the same as the ratio of BC to XY, and that's going to be the same as the ratio of CA to YZ. So for a triangle to be similar, all 6 of these things must be true. It must have congruent angles, that is, their measures must be the same, and proportional sides, that is, the ratio of the sides has to be the same. Now let's do some example problems to see how we can use that. So in this problem, these two triangles are similar, these two polygons are similar. Find the length of the missing side. So to do that, we have to first determine which sides correspond to which other sides. Then we're going to set up the proportion, and then we solve it. Okay, the first thing we have to do is determine corresponding sides. So to do that, I want to try to figure out the way I need to turn and flip this triangle so that it looks similar in the same orientation as the other one. So if I take that smaller triangle and I reflect it, and then I turn it around 90 degrees, I can now see that it corresponds to the big triangle. Now, I need to set up to determine the corresponding sides. So those two in blue, the 18 and the 30, correspond, and the one I'm trying to find and 20 correspond. The next thing I need to do is set up my proportion. And I can do that one of two ways. I can either say, on the big triangle, the small side, to the big triangle, big side. That's going to be a proportion that's going to be the same as for the small triangle, the small side, to the small triangle, big side. So I can set it up that way if I want, or I can set it up that the small, big side, that the big side to the big side needs to be in the same proportion as the small side to the small side. I can do either of those and either of those will work. So I now need to solve my proportions, so I'm going to choose to do the top one, and so I'm just going to say 20 over 30, that is the small side of my big over the big side of my big, needs to equal the small side of my small over the big side of my small. I can reduce the fraction on the left, simplify it to 2/3. Now I cross multiply. I multiply 2 times 18 and 3 times my variable. So that would be 36 equals 3x. Divide both sides by 3, and I end up with my answer of x equals 12. So I know that this side that's missing up there is 12, since I know that these triangles are similar. Let's look at a different example problem. This one is asking you to determine if these two triangles are similar, and if so, to complete the similarity statement. So to do that, I first need to, again, determine corresponding sides, set up the proportions, determine if all the proportions are equal, and assuming they are, then I have to determine corresponding points so I can complete the similarity statement. Sounds like a lot, but we can go through it. It's really not. Okay, the first thing I need to do is determine corresponding sides. So I have to put those two triangles in the same orientation and figure out what goes with what. So I could do that by, if I reflect it again and then turn it 90 degrees counterclockwise, I now see that these triangles are in the same orientation. So now I can set up my proportion by saying that those two are the biggest sides. 14 and 28 are the biggest sides. 11 and 22 are my middle sides, and 9 and 18 are my smallest sides. So to set up my proportions, I'm going to take the small triangle big side over the big side. That needs to equal the middle side over the middle side, which needs to equal the small side over the small side. So let's see if that's true. My two big sides are 14 over 28, and that needs to equal my two middle sides, which are 11 over 22, and that needs to equal my two small sides, which are 9 over 18. So now if I simplify those, divide the one on the far left by 14, I get that's the ratio of 1 to 2, 1/2. If I divide those green ones by 11, I get the ratio of 1 to 2, or 1/2. If I divide those red ones by 9, I get the ratio of 1 to 2, or 1/2. So does 1/2 equal 1/2 equal 1/2? And the answer is yes. Yes, it does. So I know that these two triangles are similar. Triangle BCD is twice as big as triangle EFG. Each of its sides is twice as big. Or conversely, triangle EFG is 1/2 as big as BCD because each of its sides is 1/2 as big. Now I have to determine the corresponding points. And I'll show you why in a second. That's for our similarity statement. So I look and I see that point B and point E correspond, just like point C and point F correspond, just like point D and point G correspond. Now that I know my corresponding points, I'm able to complete my similarity statement. And it's asking me, triangle BCD is similar to what triangle? And the answer would be triangle EFG. And it's very important that I write it in that order, because that shows me that these points correspond, that B corresponds with E, C corresponds with F, and D corresponds with G. And so I wrote it in that order because, again, B corresponds with E, they're both first. C corresponds with F, they're both in the middle. And D corresponds with G, they're both at the end. So I had to make sure that those points correspond so that I can say that so that I could write that triangle similarity statement correctly.